Hello everyone, my name is Utkarshi Chauhan and in the previous video we had discussed about the neural networks. Now in this video we are going to explore the clustering and with the help of PPT first we understand. So basically first we understand what is clustering and unsupervised learning. Clustering is an unsupervised learning technique that groups similar data pointers together based on their inherent characteristic without any prior labels or guidance. And identifying patterns, it's used to discover hidden patterns and structure in data, revealing a relationship and insight that might not be immediately obvious. And application in various fields like clustering finds broad application in finds like customer and segmentation, uh, image analysis, anomaly detection, and the document categorization. And now, introduction to the K-means algorithm. Initialization, assignment and update. The algorithm starts by randomly select K initial centroids representing the centers of the cluster. And second one is assignment. Each data point is then assigned to the cluster whose centroid is closer to it. It's based on a data matrix. And third one is update. The centroid are recalculated as the mean of all data points assigned to each cluster, refining the cluster centers. And in the next slide, we choose the number of cluster K. First, elbows method. Plot the within cluster sum of squares WCSS for different values of K. And the elbow point where the decrease in WCSS slows down in the optimal K. And second is Silhouette square. And third one is domain expertise. And in the next slide, how to implementing k-means in Python. So first importing libraries and then load and pre-process the data. Load your data set and perform any necessary pre-processing steps like scaling or feature selection, and then initiate and train the model. Create a k-means object with the desired number of cluster and train it using the fit method on your data. Now let's understand with the help of code. So firstly, we import the important libraries. In this, import numpy, matplot, library dot pyplot splt, and this generates synthetic data code. And then in the second step, generate the synthetic code, create a dataset with three cluster, n simple 300 total number of points, and n features 2 number of dimension, and n clusters number of clusters. And data to tables makes blobs. N simple is equal to n samples and center is equal to n cluster, and cluster std is equal to 1.0 comma random state is equal to 42. What does this do? And make blobs generates a synthetic data set of point distributed across a cluster, and the parameters n sample the total number of points in the data set, and n features each data point is in the 2D space xy coordinate, and n cluster data will be grouped into a 3 cluster. And then we visualize the data. Now visualize the data. plt.scatter data 0 data colon 1, and these all are that for the visualize the data. What's the purpose of this? Creates a scatter plot where x-axis in feature 1 and the y-axis is feature 2. And in the second step, apply k-means clustering. So k-means n cluster is equal to n cluster, and the random state is equal to 42. This predicted labels and k-means predict data, and these initialize a k-means clustering module with 3 cluster, and n cluster the algorithm will try to find the 3 distinct groups in the data. Random state is equals to 42 and ensure the centroid and the initialize consistency across the run. Fit dot predict and fit this computes the optimal cluster center centroid based on the input data, and then it predicts the assign each data point to the nearest cluster, return an array of predicted labels. Each label corresponds to the cluster assignment. Example like 0, 1, 2. And in the second step, we plot the results. These all are the steps for plotting the results. So points are scatter plotter of cluster data. Points are colored based on their cluster assignment predicted labels, and colors are chosen from the various color maps, so each cluster is distinguished. And cluster centroids are the marked as large red X marks, and centroid coordinates are shorted in k-means cluster centroids visualization. Now we see the output of this code. As you see in the output, this plot show the generated synthetic dataset before applying any clustering algorithm. Here's what the output represent. And then unenabled data, the point in the scatter plot are gray and unlabeled, meaning they are not yet signed to any group or cluster. And the term enabled signify that this is a raw data and no clustering has been applied at this stage. Cluster in this, and the data appears to naturally form three distinct groups visible in the plot. A group near the top left of the plot, and a group near the bottom left of the plot, and a group near the right center of the plot. These groups are centered because the synthetic data was generated with three cluster centers 3 using the make blocks function for this. And what's the feature of this? These x-axis and y-axis are labeled feature 1 and feature 2, indicating that each data point has two features dimension. The scatter plots visualize this feature in 2D space. And what's the spread of this point? Each cluster is fairly compact, meaning of the points are closely packed around their respective centers, and the spread of the cluster is controlled by the parameter cluster std is equals to 1.0 when generating the data. And what's the purpose of this plot? This is initial step before applying the k-means clustering, and it helps us visualizing the row structure of the data to see if clustering algorithm can effectively group the points. So this is all about the clustering. I hope you will understand this topic. Thank you for watching my video.